Question number 61. A capacitance C, resistance R, and an EMF epsilon are connected in series at t equal to 0. What is the maximum value of the potential difference across the resistor, current in the circuit, the potential difference across the capacitor, the energy stored in the capacitor, the power delivered by the battery, and the power converted into heat? So, in the beginning, when t equal to 0, so capacitor has no charge, hence it will behave like a short circuit, and we can say that entire potential will develop across R, and it will be equal to E. So PD across R in the beginning is equal to value of battery or EMF of battery. Now, maximum current. So it will be E upon resistance. Then when t equal to infinity, it means capacitor is fully charged. In that case, it will behave like an open circuit. So potential difference across C will be PD across C will be EMF of battery. Now, next point is energy stored in capacitors. So in such case, since PD is E and capacitance is C, so energy stored will be equal to half CV square. Here V is epsilon square. Now power delivered is VI or EI or E into E upon R. That is E square upon R. And next part is the power converted into heat. The whole power is converted into heat. So heat produced will be same as power. Now let's go to next question. Question number 62. A parallel plate capacitor with plate area 20 centimeters square. Here area is given as 20 into 10 to the power minus 4 meters square. Plate separation is 1 into 10 to the power minus 3 meter. And the resistance is given as 10 into 10 to the power 3 ohm. Here we have to find out time constant, and we know that time constant is RC. We put the value, but C is epsilon naught A upon D. So we can evaluate it. So R is 10 into 10 to the power 3 into epsilon naught, that is 8.85 into 10 to the power minus 12 into area. So plate area is given as 20 into 10 to the power minus 4. So 20 into 10 to the power minus 4 divided by separation. Separation is 1 into 10 to the power minus 3. So we can simplify it. So it will become 8.85 into 20 into 10 to the power 2 to the power. We count. So 4 minus 12 minus 4 plus 3. So this will become 17.7 into 10 to the power minus 8. Or we can shift it here decimal to 2 places left. So this power will become positive. So 0.177 into 10 to the power minus 6. So 10 power minus 6 is micro. So 0.177 into, not into, but micro second. So that is our answer. Now let's go to next question. Question number 63. A capacitor of capacitance, here C is given as 10 into 10 to the power minus 6 farad, is connected to a battery of EMF 2 volt. E is given 2 volt, and time is given 50 into 10 to the power minus 3 second. It is found that it takes 50 millisecond for the charge on the capacitor to become this much. So charge is also given, Q equal to 12.6 into 10 to the power minus 6 coulomb. You have to find out the resistance. So for charging, the equation is Q equal to Q0 1 minus e to the power minus t upon RC. Here value of Q is given and Q0 is here we can find Q equal to CV. So capacitance is this and voltage is this. So this will be 10 into 10 to the power minus 6 into 2. So Q is given as 12.6. 12.6 into 10 to the power minus 6 equal to 20 into 10 to the power minus 6 into 1 minus e to the power minus t. T is given as 50 into 10 to the power minus 3 divided by R into C. C is 10 microfarad, so we can write it 10 power minus 5. So this will become 12.6 upon 20 equal to 1 minus e to the power minus 5000 divided by R. So we can simplify it. E to the power minus 5000 divided by R equal to 1 minus 12.6 divided by 20. So it will be equal to 20 minus 12.6, it's 7.4 divided by 20. So this will be equal to 0.37. We can write this as positive power. So it will be plus 5000 divided by R equal to, this is 1 upon 0.37, which will be equal to 2.7. And we know that E is 2.72 or roughly equal to 2.7. So here we can write it as E power 1. Now we can compare the powers of E from both the sides. So we get 5000 divided by R equal to 1, which gives R equal to 5000. So that is our answer. Now let's go to next question. Here, question says a 50 microfarad capacitor is joined to a battery of 6 volt through a resistance of 100 ohm when the charge on the capacitor 2 milliseconds after the connections are met. So here again, it is the case of charging. So formula is Q equal to Q0 1 minus e to the power minus t upon RC. So Q0 we can find from here. So 20 into 10 to the power minus 6 times voltage. V is 6. So Q is RC equal to, R is given as 100 ohm and capacitance is given as 20 into 10 to the power minus 6. So 2 into 10 to the power minus 3 second. And this is coulomb. Now we have to find out the value of Q. So Q equal to Q0. Q0 is 20 into 6 into 10 to the power minus 6 into 1 minus e to the power minus t. T is given as 2 into 10 to the power minus 3 divided by, this is 2 into 10 to the power minus 3. So this is 120 into 10 to the power minus 6 into 1 minus e to the power minus 1. So we can evaluate it. E to the power minus 1 means 1 upon e. And we can do it like 120 into 10 to the power minus 6 into, this will become e minus 1 upon e. And we can put the value 120 into 10 to the power minus 6 times. E is 2.72 minus 1 upon 2.72. So 120 into 10 to the power minus 6 into 1.72 divided by 2.72. So if we multiply, so we will get it as 75.88 into 10 to the power minus 6 coulomb. And that is our answer. Thank you for watching.